Back to Learn Go from the ground up. Today we're going to be diving into one of Go's most powerful and unique features, the defer statement. If you've ever wondered how to ensure that your cleanup code always runs, then defer is your answer. By the end of this video, you'll understand exactly what defer does, when to use it, and some common pitfalls to avoid. Let's jump right in. I'm going to go ahead and do a little example here using the defer keyword. We're then going to head and print out a simple text statement. So this runs last. We'll then print out another line. This runs first without using the defer statement. Let's run this and see what happens. We get this runs first and then this runs last. When we run this code, this runs first is printed immediately, but this runs last won't execute until the actual function is about to return. You can think of it as like setting a reminder that Go will automatically execute for you. So what exactly is the defer statement? Well, the defer statement in Go postpones the execution of a function call until the surrounding function returns. And we can see this here. We're essentially saying, defer this, remember to do this print line here, this runs last, before we exit the main function. So we're basically telling Go, run all the other code, and then just at the end, before you exit the function, run the deferred statement. And you can think of this as Go's way of saying, remember to do this later, right before you leave this function. Let's take a look at a practical example where defer really shines. And this is going to be with file handling. It's probably one of the most common use cases that you will see for defer. I'm just going to go ahead and import the OS package as we will need that. So I'm going to go ahead and create a function called readFile, and we'll pass in a file name, which is a string. The function is then going to return an error if we have one. Now, we've not actually seen file reading at all yet, but hopefully it's so straightforward that it will just make sense straight away. We're going to get a file and a potential error. And we're going to grab this from OS, so the package we imported a second ago, and then we're simply going to open a file, passing in the path of the file, so the file name. In Go, you always need to check for your error, so we'll do if error does not equal nil. If it is an error, we will go ahead and just return that error. We're then going to go ahead and use the defer function here. So you remember, we said it's basically remember to do this before the function ends. And in this case, we want to remember to close our file before the function ends. So simply file.close. Nice and simple. Then just going to read out the data from our file so we can see what's actually going on. I'm going to go ahead and create a buffer. We're then going to use make to create a slice of bytes. We'll make it length of 100, as this file only has a small amount of text in it. We're then going to go ahead and either grab the error, if we have one, from the actual file. So we're going to read the file, and we're going to pass it in our buffer. And all that's going to happen here is that we're going to read the file and pass the data into that byte array we created a second ago. Oh, and I can't use the short declaration there because we've already declared error. Again, we're going to go ahead and check that our error does not equal nil. If it is an error, we're going to go ahead and, not reflect, we're going to go ahead and return that particular error. We'll then just print out that particular data from the file. So file contents, and we'll pass in our buffer. We'll then return nil from our function as we have no more errors. Let's go ahead and actually read our file. I think it's called hello.txt. Let's run this and see what we get. Okay, so we've got a slice of bytes, which is not very helpful. So one thing we need to do here is we can cast this buffer into a string. And if we run that, we will get the actual output of the file, which is hello world. One thing to notice is how we call defer file.close right after opening the file. And this guarantees that no matter how our function exits, whether it's via an error or via a panic, the file itself will always be closed. And this prevents resource leaks and is basically much cleaner than having to remember to close the file in multiple places. Another important thing to know about defer is the order of execution. Let's go ahead and do an example for this. So we'll print this line and we'll say function starts. We'll then go ahead and do a defer. and then print line. So we'll do first defer. We will do second defer, and then we'll do third defer. We'll then do another print line statement. So we'll say the function middle, and then a final one, function about to end. When you run this code, we'll see that we get the order in last in, first out for defers. Let's go ahead and run this and see what actually happens. So we get function starts, function middle, function about to end. We then get third defer, second defer, and first defer. See how the defers ran in reversed order? This is known as last in, first out behavior. And it's crucial for cleanup operations, and it's a really important thing to remember about defer. It always runs last in, first out. Here's something that often trips up many Go developers. When are the parameters to a defer function evaluated? Let's take a look at an example here. I'm going to go ahead and set a variable of x to be 10. I'm then going to go defer and print out the value of that x. So deferred x is going to be x. We'll then set x to equal 20. And again, we'll print out the value of x. So current x. And we'll print out that value. If we run this code, we'll see that we get the current x is 20 and the deferred x is 10. And this means that essentially parameters with defer are evaluated immediately when the defer statement is encountered, not when defer actually runs. So you can see here we've got the defer before we set the value to be 20. So you might expect, given that defer essentially runs at the end of the function, that it might be 20. But no, with defer, the value is always taken from the place that it is passed in. Essentially, the deferred function remembers that x was 10 when the defer statement was executed, even though we changed it to 20 later. And this is super important to remember to avoid any bugs. Never assume that deferred is going to get the value at the end of the function. It's going to remember what it was when you called defer. Let's take a look at another example of how you would use defer with file reading. Let's go ahead and create a function called copy file. We'll take our source file and our destination file, both of which are going to be strings. Again, we're going to pass in an error as the return value. Again, we'll read the file. So we'll do source and error. And this again, is going to be os.open. And we do need to import the OS, which has automatically happened for us. Again, with Go, we always need to check the error. So we'll check that the error is not nil. If it is an error, we will go ahead and return it. Remember, we always want to clean up our file. So if we open a file, we always want to close it. And of course, this is where the defer keyword comes into play. So we'll defer our source.close. We've now read our source file at this point. Or if we've got an error, we just returned. Let's go ahead and create our destination file. So we're going to have destination, and again, we're going to have a potential error. And this is going to be os.create and our destination file. Again, we'll handle this error. And hopefully you can see that the OS package is nice and simple. It's quite self-explanatory, really. You can open files, you close them, you can create files. Nice and easy. Again, we've now created and opened a file. So what we need to do is we need to defer that file is closed. Make sure we're not leaving that file open. And then finally, what we'll do is we'll go ahead and copy over the value of that file. So our destination file is going to be the first argument, and then our source file is the final argument. And finally, we'll just return an error if we have one. Let's go ahead and run this. So it's going to be copy file. Our source file is going to be hello.txt. Oh, no, it's just txt. And then we'll just do copy.txt as well. If we run this, we will see that we get the copy.txt is hello world, as we would expect. So you can see, even with two files, defer makes the code so much cleaner. And both files are going to be properly closed regardless of whether the copy fails or succeeds. And without defer, we would need to remember to close the files in multiple places and handle the errors correctly. Just remember, if you open something, you just close it with a defer straight away. Before we wrap up, let's explain 2 common mistakes that developers make with defer. First, you need to be really careful with defer inside loops, as each defer statement gets queued up. Remember, it'll last in first out order and won't execute until the function returns. We're not actually going to run this code, but let's use an example of opening 1,000 files and how that's bad with defer if you do it wrong. So we've got a for loop here. We'll just say until I is less than 1,000. We'll then increment I. We'll then grab the file and we will just do os.open. And we'll just do, as an example here, format.sprintf. So we'll just format this string and we'll just say file and then the number of the file as a text. We can then go ahead and pass it in I. And this would essentially just read files 0 to 1,000 with file number name. You then might think that the correct thing to do would be defer.close within the for loop. But in this example, you could end up with 1,000 files open because none of the deferred closes execute until the entire function itself finishes. So it's not actually going to execute any of these defers until you hit this line here. And this can be really bad because you can run out of memory or it can crash, right? Opening 1,000 files, 10,000 files, that's going to take a lot of memory. So the correct way to do this would be to use as a good loop. Let's take a look at this example. So again, I'll just copy this because it's nice and easy for our for loop example. So rather than opening up the files here, what we would do is we would call a separate function called process file. Again, we can pass in the file name and we'll just do file%d.text, passing in the number again. We then go ahead and create this process file function and it's going to take file name, which is going to be a string. And in this function here, we will do what we need to do. So we're going to open up the file. So os.open. This is going to be the file name again. And we would then do defer file.close. Of course, we would need to handle the errors there, but that's how you would handle that. And this basically means that as soon as this process file function exits, we call defer and we close the file. So you're not running into the case where you've got thousands of files open and you run out of memory. Another error that people often make with defer is calling it before we actually handle errors. So let's take a look at that example. So here, again, we're just going to open up a file and potentially get an error. So os.open, and we'll pass in, I don't know, hello.txt as that's our file. The error that you can make here is that you go ahead and call defer on the file before we've actually handled that particular error, and then do if error does not equal nil, we would return the error. This would need to return error here. The issue here is that if this open actually errors, we're going to go ahead and call file.close, even though the file hasn't actually been opened at that point. Instead, you always need to call the defer after you've handled the error from your particular action. Only call it if you have been successful with your file open, essentially. Otherwise, there's no point in closing a non-open file. And that's defer in Go. It's a simple concept, but incredibly powerful for writing clean and reliable code. You can use it for cleanup operations, error handling, and ensuring resources are properly managed. The key points to remember: defer runs when the function exits, and multiple defers run in last in, first out order, and parameters are evaluated immediately. So thanks for watching. If this helped you understand defer better, give me a thumbs up and subscribe for more Go tutorials.